Now, in real life, very often you will encounter systems where you get a pair of charges equal in magnitude, opposite in sign, separated by a very small distance. Like it happens in a charge separation. Separation is really small, of sometimes of the order of few microns or so or less, right? So to have an independent study of such a pair will make sense because that such a pair is frequent. We have a charge minus q and a charge plus q separated by a distance d. Now, this d is very small. Now, what does this mean? It means that when I look at these surroundings, various points p in the surroundings, any point p in the surrounding, let me look at the negative charge from the perspective of the negative charge. This is r and theta. This r and theta will determine, combination will determine all points in the surroundings. But we will look at the effect of this. We will look at the electrical effect of this pair only for points where d is much smaller compared to r. Only for such p's we will explore the effect of this pair, where r is much smaller compared to, d is much smaller compared to r. And such a pair for which the effects at points p commensurate with this is examined is called a dipole, Such a pair is called a dipole. We define some basic things for a dipole for convenience. We define a vector for the dipole called the dipole moment. A dipole moment vector p. This vector p is directed from the negative to the positive charge. This dipole moment vector p is directed from the negative charge to the positive charge. In chemistry they do theek ulta, right? Yes. So dipole moment is defined from the negative charge to the positive charge, the dipole moment vector p. And p is defined as the magnitude of the two charges. Q is the magnitude of the two constituent charges into the vector d. D is the vector from minus q to plus q. This d has magnitude d. This vector d is from minus q to plus q. That's defined as the dipole moment. That's defined as the dipole moment. Now, q charge মানে পজিটিভটা যেটা আছে এটা নেগেটিভ চার্জ আছে, এটা পজিটিভ চার্জ আছে। হ্যাঁ না 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 দেখো আচ্ছা একটা জিনিস কেমিস্ট্রিতে কি দেখেছিস, যখন একটা চার্জ সেপারেট হয় so it's like a plus q minus q kind of a situation only na. So we talking of this very special case, unequal hole if I can break it up into other constituent dipoles তাহলে করা যায়। I'll explain that also. If I can convert that into an equivalent dipole, that means I can break it up into several minus q plus q pairs, then there will be several dipoles. Kintu একটা dipole মানে হচ্ছে 1 minus q and 1 plus q. It's possible that I am able to create a series of minus q plus q over d. That is, if I can do that, then there are several dipoles. We will look at one dipole. So the dipole moment vector is of magnitude q into d, q into the separation between the two charges. That's the magnitude of the dipole, and it's directed from the negative to the positive charge. It's directed from the negative to the positive charge. Now, obviously, what do I want to do at P? When I say I want to know the electrical effect at P, at a certain point P, every P, so you know, we are measuring from the negative charge. We are measuring from the negative charge, my R's, and my theta is the angle that this R makes with the dipole moment vector. Right, this theta, so the dipole moment vector is this. This is where the negative charge is. This is my R and this is my theta. And this is a point P. Theta is the angle that this R makes with the dipole moment vector. Right, this is the direction of the dipole moment vector. Clear? Now obviously I want to compute at P the electric field and potential because of this pair. Electric field and potential. And use the approximation that small r is much larger than d. This is what I want to do. Now let me compute the potential at the point P. Suppose this distance is r, this distance is say r1. This distance is r1 say. Okay? So the potential at P would be potential because of this plus potential because of this. Right? The potential at P is defined as kq 1 by r1 minus 1 by r. Do you realize this? K into minus q by r, k into plus q by r1. Right? Now, I want to eliminate r1 because I want to write everything in terms of r and theta and d. D is a property which is the separation between the two charges. R and theta I define for the point P. I want to eliminate r1. I want to be able to write r1 in only and exclusively in terms of r and theta. This is what I want to do. Right? I can apply cosine rule to this. R1 square will be r square plus d squared minus 2dr cos theta. Yes or no? That's cosine rule? Yes. Right? And from there I want to dispense r1. I want to dispense r1. So r1 square is r square plus d squared minus 2rd cos theta. Hey, one thing. 1 plus x power n, when x is numerically much less than 1, I told you is approximately 1 plus nx. Remember one of the earlier classes, when x is numerically much smaller than 1, 1 plus x power n can be approximated to 1 plus nx. Now, r is much larger compared to d. I therefore choose to take r square common from this expression. And cos theta obviously will be numerically less than 1. So if I took r square common, then this is like 1 plus d by r whole squared minus 2 into d by r into cos theta. Yes or no? Now again, first level of approximation. If d is much smaller compared to r, d by r whole square will be even smaller. I can neglect d by r whole squared, right? So first level of approximation is, this is like a r squared into 1 minus 2 d by r cos theta. That's r1 squared. Raising both sides to the power minus half. So I get r1 to power minus 1 equals r to power minus 1, raising both sides to power minus half, into 1 minus 2 d by r into cos theta to the power minus half, right? Yes or no? Hey, d by r is really small. Cos theta is less than 1. So this number is like a small number, numerically much less than 1. 2d by r cos theta is a number smaller than 1, and 1 plus x power n then can be approximated to 1 plus nx. So this is like r to power minus 1 into 1 plus minus 2d by r cos theta into minus half. N is minus half here. Can be approximated to this. 1 plus minus 2d by r to power minus half is 1 plus nx. N is minus half, x is minus 2d by r cos theta. Clear? This is r to power minus 1, approximately 1 plus d by r cos theta. D by r cos theta. Yes or no? Clear? So we have r1 to power minus 1, that means 1 by r equals 1 by r into 1 plus d by r cos theta. Yes or no? And if I take 1 by r1, sorry, so 1 by r1 minus 1 by r, I transpose this is like a d by r squared cos theta. D by r squared cos theta. 1 by r1 minus 1 by r is like a d by r squared cos theta. Bol, ठीक है तो? Now, hey, this is what I wanted. I wanted 1 by r1 minus 1 by r in terms of r and theta, na? I wanted 1 by r1 minus 1 by r in terms of r and theta. This is what I get, right? So this is like a kq into d by r squared cos theta. That's the potential at the point P. Confused क्या? Anyone? अच्छा, Q into D क्या होता है? Dipole moment, isn't it? Magnitude of the charge into D will give me the magnitude of the dipole moment. So this is like Q into D replaced by the magnitude of the dipole moment. So this is like Kp cos theta by r squared. That's a potential at the point P. That's a potential at r theta. That's the potential at r theta. Kp cos theta by r cube. Yes or no? Yes, given r and theta with respect to the negative charge, theta is the angle that r makes with the dipole moment vector. The dipole moment vector is like this, from the negative to the positive charge. Then the potential at that point is given by Kp cos theta by r square. Now, can I remove this? ওটা আনা ওই এটা তো পার মাইনাস হাফ করলাম, ঠিক है बेटा? Got me? So sometimes, you know, we don't write minus q plus q. What we do is we just designate a dipole moment vector. We just designate, दो लिखने की जगह we just write the dipole moment vector, and various points P are designated in terms of r and theta. R and theta. This is what I do. This is customarily done, right? Can I wipe this off? So, the dipole moment vector, I repeat, is from the negative to the positive charge. As far as sane people are concerned, chemistry people do it ulta. This is a point P. This is R. This is theta. This is the dipole moment P. P, magnitude of P is Q into D. So for different thetas, I'll get the potential at different points. Potential at different points. I need the electric field at various points now. At r theta, I also need the electric field. Nahi kya? Now, whatever be the electric field at P, because of that pair, you know, suppose E was the electric field at P. Suppose E was the electric field at P. I could have resolved this electric field in two directions, two mutually perpendicular directions. One would be an electric field component in the radial direction, in the r direction. This is the radial component of the electric field. Radial component of the electric field. And a component perpendicular to r. A component perpendicular to r, that's called the tangential component, or sometimes they call it the theta component. This is called the tangential component. Sometimes they call it the theta component. They call it the theta component. I want to find ER and E theta. So if I know ER and E theta, I would know E. E would be root ER squared plus E theta squared, right? Clear? Now, if you remember, electric field in a given direction, suppose this is the x direction. Electric field component in the x direction would be negative of the rate of change of potential in that direction. Electric field in a given direction would be negative of the rate of change of potential in that direction minus dou v dou x. So the electric field, this is my r direction, is negative of the rate of change of potential in the r direction. Negative of rate of change of potential in the r direction minus dou dou r of v. V is kp cos theta by r squared. Differentiate this with respect to r, keeping theta constant. So kp cos theta comes out. If you differentiate 1 by r squared, you get 2 by r cubed. You get 2 by r cubed. So this is like 2 kp cos theta by r cube. 2 kp cos theta by r cube. That's the radial component of the electric field. That's the radial component of the electric field, right? No. It will be wrong to say E theta would be minus dou v dou theta. Bullshit. Hey, dimensionally this is wrong. Look at the dimensions of this. This is volts and meter. This is volts and radians. How can this be, right? Yes or no? This will be dimensionally wrong. It has to be volts per meter kind of a thing. So this is not right, right? What? Why? Again, this is my point P. This is theta. This is my dipole moment vector. This is my dipole moment vector. This is r. Now what I imagine is, I imagine in a direction, this is my tangential direction. This is my ER direction, this is my tangential direction. E theta. This is my tangential direction. In this, I move a small amount perpendicular to r. This is a small displacement perpendicular to r. Right? And when a unit positive charge is moved slightly in this direction, what's the only force acting on it? E theta. ER will have no component in this direction, right? Now, when I move a small amount in this direction, that means this would be a small angle d theta. This is r, this is r. This would be almost like an arc of a circle centered at O and radius r, subtending an angle d theta at the center, right? So this length from here, this displacement is r d theta, as if r is kept constant, as if r is kept constant. Now, what is the work done by the forces of the field? Work done by the forces of the field would be E theta, that's the force of the field acting, into r d theta, right? Keeping r constant, right? R is maintained constant during the small displacement, right? And that must be negative of the change in potential? That must be negative of the change in potential, yes or no? By definition, work done by the forces of the field is negative of the change in potential. So this gives me E theta as minus dV by r d theta, keeping r constant. But if you differentiate v with respect to theta keeping r constant, that's called dou v dou theta. That's called dou v dou theta. Differentiate v with respect to theta keeping r constant, that's called dou v dou theta, isn't it? Differentiate v with respect to theta maintaining r constant, that's called dou v dou theta. So E theta would be minus 1 by r dou v dou theta, right? Dou theta of v. So what is E theta? E theta is minus 1 by r dou v dou theta. What is v? V is kp cos theta by r squared. Differentiate with respect to theta keeping r constant, kp cos theta by r squared. R square, kp, etc. will come out. So this is like kp by r cubed, kp by r cubed sin theta. No, minus cut jayega na, minus sin theta. But so that's a tangential component, that's the radial component. Radial component is 2 kp cos theta by r cubed. Tangential component, the theta component, is kp by r cubed sin theta. Kp by r cubed sin theta. Theta component মানে কি হচ্ছে? I'm moving perpendicular to the radius. আচ্ছা, এটা এই মালটা. If I take a unit positive charge in this direction, ER will have no component in this direction, right? What's the force acting on a unit positive charge because of the field? E theta. Now, when I displace by a small amount d theta keeping r constant, then this length is approximately r d theta. This is almost like the arc of a circle. This is almost like the arc of a circle. For all practical considerations, this is almost like the arc of a circle, r d theta. Work done would be E theta into r d theta, that is negative of the change in potential. The net electric field obviously would be root ER squared plus E theta squared. Yes or no? Now, there is another way one could express this. Let me tell you that also. See, this is the vector P, the dipole moment vector P. This point P, this vector is R. From O to P, this vector is R. Now, V at r theta, as we have obtained, is kp cos theta by r squared. Would you mind believing, where magnitude of r is small r, would you want to check that this is the same, this angle is theta between P and R? Would you mind believing that this is P dot R by R cube? Because what is P dot R? P into R into cos theta, and that one R will get cancelled with this and produce R squared. So that's a P dot R by R cubed. So P dot R by R cubed, that's in vector notation you write the potential at a point R theta. समझ में आया सबको? बहुत है, अभी 2-1.5 घंटा और लगेगा dipole moment वगैरह पढ़ाने में, but I'll let you go because beyond this point you will actually start to curse me.